Good morning. This lesson is from our Trig-Precalc classes, but before I get started, I'm going to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this lesson, but I'm going to title it how I title it in the title. But what I am sure of is our one goal for the day. Our first and only goal is going to be to construct the unit circle using a straight edge and a compass. And so let me just explain what we want to do here. We want to build the classic unit circle using the straight edge and compass. And the reason why I want to do this in this method is I want you guys to understand why the coordinates are the coordinates in the classic unit circle. You only need to know how to construct an equilateral triangle and bisect angles using a straight edge and compass. So we're going to go over those steps together, and they're pretty easy to use. Materials needed. The first material that you need is a straight edge, which is a ruler, and you can get away with basically anything. Edge of a book, a folded piece of paper, that'll be good enough. The second thing we need is a compass. If you don't have a compass, Home Depot makes a great compass. It's like currently $279. The year is 2021. It's October 2021, like $279. So maybe 2 weeks after this video is made, due to inflation, they'll be, I don't know, sold for $55. And the third thing we're going to need are scissors. Make sure you don't run with those. All right, so here's an outline of the process that we're going to go through. And again, I'll walk you through the steps when we get to the steps. The first thing we're going to do is we're going to create a unit length. I recommend this being 3.5 inches. A unit length is a length that we call 1. So in this exercise, our length that we're calling 1 is actually 3.5 inches. The second thing we're going to do is we're going to construct an equilateral triangle with our unit length and bisect one of the angles, creating a 30, 60, 90 triangle. So I'll go over why we're making it with unit length when we get there. The third thing is we're going to construct a 45, 45, 90 triangle with our unit length using the properties of a square. Now, I didn't mention this in the process, but we're also going to calculate the side lengths. Okay, so let me add that right now while I'm thinking about that. We're going to calculate the side lengths. Calculate the side lengths because we need this. This is going to tie in to the coordinates on the unit circle that we're going to find. So we're going to calculate the side lengths for step 2, and we're going to calculate the side lengths for step 3. After we build those and calculate the side lengths, we're going to cut out the triangles. Fifth, we're going to construct a unit circle with our unit length, which means we're going to make a circle with radius 3.5 inches. And finally, we're going to use our triangles to create coordinates, or to find the coordinates. So again, the point of this exercise is to have you guys physically make a unit circle and hopefully have a better understanding of why the coordinates are the coordinates of the classic unit circle. And so instead of me asking you to memorize, you'll be able to remember because we actually made one. So let me clean all this up and we'll start jumping right in and going through the outline of the process. So let me clean this up and I'll be back. All right, I'm back. So I'd like to go ahead and go through some of the constructions to show you how we're going to construct our unit circle. So the very first thing we're going to do is we're going to create our unit length, which is a 3.5 inch unit length. So this length that we're going to call 1 is actually 3.5 inches long. So what I'm going to do is just use my straight edge, draw a line across the top, put a dash, and then measure off 3.5 inches. So at 3, I should go to 6.5. And I'm going to use this to reset my compass so that I guarantee that I'm back to my unit length. So we're going to consider this length 1. That's our unit length. This is length 1. So let me set my compass up. So now I have my compass at a length of 1. Okay. So my compass is now at a length 1. I'm going to go ahead and now make my 30, 60, 90 triangle. I'll make that off to the bottom right here. So I'm going to start off with a dot. Let me double check and make sure that I'm still at length 1. All right. So making an equilateral triangle is a pretty easy construction. You make about a quarter of a circle, put a dot on the arc that you just made, Let's make sure we're still at our unit length. Come over here, make another quarter circle. And what we're going to do is we're going to connect some points here. So I'm going to connect that to that. I'm going to connect that to that. And I'm going to connect that to that. Okay, now I've made my equilateral triangle, which the characteristics of it is it has all 60-degree angles and the length is 1. I'm going to now bisect this top angle here so I can adjust my compass now. Make an arc, put the needle where it crosses the triangle, draw down, switch it off. And now I connect these 2 points. And what I've done is I've cut the top angle in half, and I'll go over this a little bit more on the whiteboard, what I'm actually doing. But I've made 2 little identical triangles. That's a 60-degree angle. That has to be a 30-degree angle. All 3 angles have to add to 180, so I have 60 add 30 gets me to 90. That makes that have to be a 90-degree angle. So I've made my first triangle. I'm actually going to cut this one out. And now I'd like to make my second triangle. So it looks like I need a little bit more space. So what I'm going to do is I'm going to turn this paper to the side here. And I'm going to draw a segment like so, all the way across my paper. And I'm going to put a dot about right here. Okay, I'm going to come back and make sure my compass is open to the right length here. Go back to our so I'm going to go that length right here. So I'm actually going to now bisect this angle, which is a straight angle, and this angle, and I'm going to make 3 sides of a square. All right, so the very first thing I'm going to do is I'm going to make an arc. And I'll make another arc over here. Come back, open up my compass a little bit. So needle, pencil goes like that. Make an arc. Switch it up. Make another arc, do that on the other side. Needle there, pencil there. Oh, pencil there, make an arc. Switch it up. Make another arc. And now I can connect these points here. And again, what I'm doing is I'm making a 90-degree angle. I'm going to make this a little longer. And I'll make this side a little longer. Okay, now I need to go back and recalibrate, because what's going to happen here is I'm going to get that length, and I've made 3 sides of a square. And if I just make some diagonals of a square, which I don't need the 4th side for, I'm going to get my length, make some diagonals here of this incomplete square. Let me make sure I'm still on there. And what I've done is I've now built my 45, 45, 90 triangle. So these are going to be the 2 triangles that I'm going to cut out. That'll allow me to construct my unit circle. So I'm going to cut this little triangle out here, and I'm going to cut this little triangle out there, and I have my 2 triangles that I need to construct my unit circle. So let me go ahead and pause this, prep the whiteboard so I can show you how we're going to calculate the side lengths of these things. So I'll be back. I'm back, so let's go ahead and continue with this lesson. So I've recreated the constructions that I did on that paper on the board, and I highlighted the triangles that we're actually interested in red. So this is one of the triangles that we're going to cut out, and this is the second triangle that we're going to cut out. And I also put on the board the unit length. You need to think about this as length 1. We created a length 1. Alright, so let's talk about this first red triangle. So we want to find the side lengths and the angle measures of the triangles we constructed. First of all, every side length of this triangle that we built right here has length 1 because we used our unit length as the size for this triangle. So length 1, length 1, length 1. Not only that, because it's an equilateral triangle, what that means is every angle in the original triangle, ignore this for a second, but every angle must have a measurement of 60 degrees. So 60 degrees, 60 degrees. This angle right here is actually 60 degrees as well. Now I bisected 60 degrees, which means I cut it in half. And before I go any further, the three angles of this equilateral triangle must add to 180. So 60 and 60 make 120. That means this must be 60 as well. Now again, we cut that in half. So this must be 30. That must also. This must be 30 degrees. That must be 30 degrees. And because the three angles of this little red triangle add to 180, and I have 90 degrees already, that forces this angle down here to be a right angle. Now, I've figured out all the angle measures of my red triangle, but I haven't figured out all the side lengths. So we can go a little reasoning on this. I can make the argument that this red triangle is congruent to this little black and red triangle, and I have many different ways to say I can argue that. This angle should be 30 as well, so I can legitimately say side, angle, side, and determine that those two triangles are the same, which would force this length to be the same as that length, because if two objects are the same, then the parts that make the objects in the same positions must be the same. So we can very quickly conclude that that must have a length of a half. So we know one side length is 1, the side length is a half, and we have one more side length to find. So I'd like to erase some things and further highlight the triangle we're interested in and show you how we're going to find that last side length. Okay. So again, this side length is 1. This side length is a half. This side length is unknown, so we'll call that x for now. When you have right triangles, you can use the Pythagorean theorem to find the length of the missing side length. So the square of the sum of the legs will add up to the square of the hypotenuse. So I get x squared plus 1/2 squared, and that's going to be equal to 1 squared. Well, x squared stays x squared. A half of a half is a quarter, so it's 1/4. And then 1 times 1 is going to get you a 1. Now, I'm going to, instead of saying 1, I'm going to say 4/4, because I know that I'm going to have to subtract a 1/4 to both sides, which is going to get me to x squared is equal to 3/4. Now to get rid of that square, I have to square root everybody. So I'll square root u, I'll square root u, square root u. Now I'm not going to add a plus minus because I'm talking about length. And so we're going to have the length of the unknown side is equal to the square root of 3/2. So this is no longer x, it's square root of 3/2. So I've found all the angle measures for this triangle that I'm going to cut out. I've also found all the side lengths for this triangle that I'm going to cut out. And they're all based on this length being what we call 1. Alright, we have another triangle that I'd like to find the lengths of. And so let me go ahead and just highlight a few facts. So I mentioned that I was making this triangle out of the fact I was making a square. So what I did was I took our unit length, made a right angle off of it, And so I know for sure that's a 90-degree angle. I know for sure that's a 90-degree angle. I then took our length and I put it up the vertical side on both sides, and now I know how tall my square would be, and I drew diagonals. Now diagonals do something very special in squares. They are perpendicular to each other, so I know for sure that this has to be a right angle. And not only that, they bisect opposite sides. So really quickly I can conclude that this must be 45 degrees and this must be 45 degrees. So I found all the angle measures very quickly on this, but now I need to find the side lengths. Now again, this length was created by our unit length, so we're going to call this length 1. I'm going to erase all of this off so we can just focus on the triangle that we're concerned with here, and we can calculate the missing side lengths on this one. Now, because I have a triangle that has two angle measurements that are the same, what that means is the side lengths opposite those must also be the same. So I can call this side length x, and I can also call this side length x. I want to make sure I'm not going to go off the whiteboard because I really hate having to refilm these things. Okay. So now I can actually calculate my unknown side lengths because they're the same. Again, I'm going to use the Pythagorean theorem here. I have x squared plus x squared is equal to 1 squared, which gets me to 2x squareds. That's equal to 1. Alright, let me divide away the 2 so I can get my x squared by itself. And now I have x squared is equal to 1/2. So just like before, I'm going to square root everybody. So I'll square root u, I'll square root u, and I'll square root u. And we're going to get that x is equal to 1, because the square root of 1 is 1 over the square root of 2. Well, you're not allowed to have a square root in the denominator. So what we can actually do is we can actually multiply this by square root of 2 over square root of 2. This is called rationalizing the denominator. In the denominator now, I have square root of 2 squared. Square roots and squares cancel each other out. And 1 times square root of 2 is square root of 2. So now I'm left with my unknown side length as the square root of 2 divided by 2. So now I know all the lengths of my triangles that we constructed. I know all the angle measures of the triangles that I constructed. And now we can use this to create our unit circle. So let me go back over to my table where I'm doing the constructions, and I will show you how we're going to construct our unit circle and then how we're going to find our coordinates. So let me get over there and get that set up, and I'll be back. Alright, I'm back. So as you can see, I've cut out my little triangles, and I've actually labeled the angle measures and the side lengths on both sides for my 45, 45, 90 and for my 30, 60, 90. And I needed to label those so I know where I'm at when I build my unit circle. So I'd like to build my unit circle, and I'm going to build my unit circle on a separate piece of paper. And what I've done is I've drawn a straight line about in the middle of the paper. I'm going to use a pencil so I'm not taking away from my unit circle, and this will be a lighter mark. I'm going to again make a right angle off of this, and then that way I can guarantee that I have a perpendicular x and y axis here. So I'm literally constructing all parts of this. Alright, there we go. So now I have a guaranteed perpendicular x and y axis. Alright, and now I'm going to go back to my unit length, because I'm going to use that to make my radius of my unit circle, which will have a unit length, or a length of unit 1. So let me, for the last time here, calibrate my compass. Oh, the cricket's back. Alright, I calibrated it. And so now I'm going to try my best to make my circle there we we go. So that is my unit circle. And now I get to show you why I made these little triangles to help me with my unit circle, or create some coordinates on my unit circle. And I wanted my students to understand that the coordinates of a unit circle come from triangles that we can actually construct. So if I'd made this correctly, the hypotenuse of my triangles that I created should end up on the unit circle, and I can use my side lengths of my triangles that I created to calculate, not calculate, but state the coordinates of these points. All right, so on the unit circle, this point right here is considered 0, 1. Not 0, 1, 1, 0. Sorry, I learned my coordinates. All right, 1, 0. So what I'm going to do is I'm going to put my triangle that I constructed onto my unit circle, where vertex is at the origin and the other point is on the unit circle. So I know that that point that I just put a dot at has an x value of square root of 3 over 2 and a y value of 1/2. And this is the coordinates that I get when I'm at 30 degrees. Now the next point that I can find on my unit circle is when I put my 45, 45, 90 triangle on my unit circle. And the point that I'm going to put right here has coordinates of x coordinate square root of 2 over 2 and a y coordinate of square root of 2 over 2. All right, and now I'm going to use my other triangle to make my coordinates at 60 degrees here. So again, you can see that the hypotenuse is lining up, so I actually did do this right, which is awesome. So I have an x value of 1/2 and a y value of square root of 3 over 2. So x value of 1/2, y value of square root of 3 over 2. And that's at 60 degrees. Here I have the x value of 0 and the y value of 1. All right, so now we're going to be into the second quadrant. The x coordinates are negative, the y coordinates are still positive. Now this is going to be a little bit funny how I do this. So on the first one, my sides of my triangle were on that part of the axis. On the second one, my triangle is on the vertical part of the axis. So this now represents 120 degrees. My x coordinate is over, it's going to be negative 1/2. And my height here is square root of 3 over 2. And I do apologize for how poorly I write. Oh, and I didn't put the dot, so let's put that dot there. Alright, and then we can come and use our 45, and again, we want to just go off of that right there. And we got one more that will do the 60 degree. So that's actually, 135 degree coordinates. And then this one will be 150 degree coordinates, which will have an x value of negative square root of 3 over 2. And a y value of 1/2. All right. The coordinates here are negative 1 and 0. And again, this is just an exercise to understand where the coordinates come from for the classic unit circle. All right, so now we're on to our third quadrant, and I'm going to line the triangle off of that side of the x-axis. So this actually represents the coordinates at 210 degrees. Both the x and the y are going to be negative. X is negative square root of 3 over 2. Y is negative 1/2. Let's do negative let's see, 80 and 45, negative 225 is there. And again, it's negative square root of 2 over 2 and negative square root of 2 over 2. And let's finish that off. And we got one more in this quadrant. This one will be a negative 180 and a 60, so that's 240. So this is my coordinates at 240 degrees. Negative 1/2, negative square root of 3 over 2. And then at negative 270, it's 0, negative 0, 0, negative 1. And now we have one more axis that we're going to come off of. And so this is 270 and 30 degrees, which takes me to 300 degrees. So it has an x value of 1/2. So now we're positive x. Still negative y because I'm below the x-axis. So it's 1/2 negative square root of 3 over 2. Let's get this guy. So it's 270 and 45 takes us to 315 degrees. And that's square root of 2 over in the x direction. And negative square root of 2 over 2 in the y direction. And we have one more. We're going to add 60 degrees to our 270, which takes us to 330 degrees. And my x value is square root of 3 over 2. And my y value is negative 1/2. So here's how we find the coordinates of the classic unit circle. And I wanted again to have you guys understand that those are created from triangles that we can actually construct. So I'm going to go ahead and end this lesson here. Again, I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye.